Hello, this is Mrs. Pullen for AP Statistics on the Random Variable Unit, and we're on lesson 4.15. In this lesson, we're going to go over permutations and combinations. So, what is a permutation? A permutation is any arrangement of items in a particular order. Often think about ways of arranging words, ways of arranging people in a line. And so here's our first example. How many different three-letter arrangements are possible with the letters in the word cat if each letter can only be used once? So we can actually do this by hand to get a sense of how to do this. So cat would be one way, and then we can do CTA, and we can do TCA or TAC. We can also do ACT and ATA. ATC. And I think that's the last of them. There are no other options. So we have 6 ways that we can arrange the letters in cat. Is there another way we can do this? Because right now with 3 letters, it's fairly easy for us to determine this. But if we have something like 10 letters, it would be a long time for us to figure it out. So one way we can do it, I call this the slot method. There are 3 letters in the word, and we have 3 ways we can choose the first letter. Once we choose that, since no letters can be repeated, we have 2 ways for the second. And finally, we only have 1 option left for the third. And we're going to just multiply that together. This is known as the counting principle. So this is another way. And I'm going to be showing you more in a minute. Number 2. How many different 6-letter arrangements are there of the letters in the word random if each letter can only be used once? So now we have many more different arrangements, so I don't want to list out all possibilities. I just want to find out the number of ways. So let's start out by using the slot method. So we're arranging 6 letters, so we have 6 slots. So we have 6 ways to choose the first, 5 ways to choose the second letter, 4 for the third, 3 for the next, fourth, 2, and 1. And then we would multiply it out. Well, we have a symbol that we can use that means to multiply items out, and that's called the factorial. And it's represented by an exclamation point. So another way of writing 6 times 5 times 4 times 3 times 2 times 1 is actually 6 factorial. And if you go into your graphing calculator, we can actually type that in. So we have the number 6. And if you look on the same line as A, B, C, D, E, F, G to the far right, click on it, and the second column is that symbol P. And notice that's 720, and that saves a lot of time. So this is 720 ways. Again, this is known as the factorial symbol. And in general, you would start off like n factorial actually equals to n times n minus 1 times n minus 2. And you keep on decreasing by 1 until you get to 1. When you multiply it out, that is the number of arrangements. There's actually another way we can do that, and that is the permutation function and the permutation formula. And I'm going to show it to you, although for the problem we just did, the easiest way is just listing out 6 factorial. I do want to show you how this formula works because we're going to need it for future problems. So the permutation formula lets us find the number of arrangements or permutations of n items chosen r at a time. So the n is always to the left of the function. So we're choosing, in this case, we're going to be choosing from 6 letters. We want to arrange all 6 in order. So if I substitute in the formula, it would be n. This is n, this is r. So 6 factorial over 6 parentheses 6 minus 6 factorial. So that's 6 factorial over 0 factorial. 0 factorial is always 1, but we'll type it in anyhow so you can see. So we already have 6 factorial. So 0 factorial is 1. So 720 divided by 1 is just 720. So it didn't really do anything different. But now let's take a look at the next problem. We have a combination lock, and it will open with the right choice of 3 numbers. So we have 3 numbers that we have to choose, and we can select them from numbers 1 through 30 inclusive. And we want to find how many different lock combinations are possible, assuming we can't repeat any of the numbers. Now, this is a permutation because order matters. So again, we can do this a couple of different ways. We can use that slot method. We're only choosing 3 numbers. So we're going to choose 30 for the first. Once we choose that number, so we can't have any repeats, we have 29 for the second. And then finally, we have 28 for the third. And we can simply type that into the calculator. So 30 times 29 times 28. Whoop. And we get 24,360. That's a lot of ways. So that's one way we can get our answer. And that's probably what I would typically use. But let's try the formula because I want to show you how we can actually do this in the calculator as well. So we have, if I were substituting in the formula, I have 30 ways I want to arrange from 30 items, I want to arrange 3 letters, or 3 numbers in this case. So if I substituted by hand in the formula, that would be 30 factorial over 30 minus 3 factorial. So that's 30 factorial over 27 factorial. Now, I didn't have a fancy calculator, so when I grew up, we would do the following. We would go 30 times 29 times 28 times 27 factorial divided by 27 factorial. And we would be left with the 30 times 29 times 28, which we already calculated to be 24,360. But now let me show you the calculator because it's very handy. So we can actually type the 30p3 into the calculator. So in the calculator, it's written something like this, NPR, and then you would put in 30, the parameters 30 and 3. So the 30 represents the number of items we're choosing from, and this is how many we're selecting at a time. So we go into our graphing calculator. We're going to hit Menu, Probability, Permutations, and look at this, 30, comma, 3. And it gives us the same answer. That's a beautiful thing, this calculator. Number 4. From a club of 24 members, a president, vice president, secretary, treasurer, and a historian are being elected. and how many ways can the offices be filled? So here, because the order of the committee members matters, like who is president, who's vice president, and so forth. There's a different responsibility depending um, on what position you are. So the order of how you're choosing these people matter. And so from the 24 members, we are arranging how many? 1, 2, 3, 4, 5 positions. So let's just enter this in the calculator. So in the calculator, you would go N, P, R, and in parentheses, 24, comma 5. That's just how you enter it in the calculator. Remember, this is N, this is R. N is always to the left. So you would do menu, probability, permutations, 24, comma 5. Oh my gosh, that's a huge number, right? So we have, let's write this down, 5,100,480 ways. Thankfully, I did not have to list all of them out. We're now going to go over a concept called a combination. And a combination is an arrangement of items in which order does not matter. So the key thing is the order does not matter. So since order does not matter in combinations, we're going to have fewer combinations than permutations, since combinations is actually the subset of the permutations. It's choosing something where we're not worried about rearranging the people chosen. Okay, so how do you calculate this? So there actually is a combination formula. And so the formula states from n items, we're choosing r at the time. And it's equal to n factorial over r factorial times n minus r factorial. So for this example, we're going to do it by hand, and then I'm going to show you how to do it in the calculator. So the order does not matter in this case, because it's not as if the first person you're choosing is going to be president. You're just choosing 3 people, and they're all have the same level on that team. Okay, so 18 is my N, and I'm selecting R. So 18 C 3. I often say C is choose, so 18 choose 3. So if I were doing this by hand, this would be 18 factorial, that's my N, R factorial, or 3 factorial, and then 18 minus 3 factorial. So that's 18 factorial over 3 factorial, 15 factorial. And years ago when we did this by hand, what I would do is go 18 times 17 times 16 times 15 factorial over 3 factorial is 3 times 2 times 1. And then I would just rewrite the 15 factorial. This is what I did growing up because we didn't have fancy calculators. And 3 times 2, or 6, goes into 18 3 times. And then we would multiply 3 times 17 times 16. And that is equal to 816 ways. It's a lot of ways. That's one way of doing this problem. But we can actually just plug this into the calculator. And so in your calculator, there's command NCR. And in the parentheses, you would put the parameters, in this case, 18, comma 3. So this is N, this is R. So we would go into our calculator. I'm just going to start a new calculator page so it's a little easier for you to see. So you would do menu, probability, combinations in this case, because order does not matter. And you would do 18 comma 3, and you get the same answer, but a lot faster. Just a couple more problems. Number 6, horseback riding is a popular college class option. On the first day of class, 30 students show up, but only 12 students will be able to actually take the class. So we have to choose. The stable only has 12 horses. How many ways can 12 students be chosen from the 30 that showed up? Well, order does not matter. It does not matter which student comes first or which they don't get preferential treatment. So we're just choosing from the 30, 12. So order does not matter. So we're going to just use the NC or R function, and we're going to just do it by hand, by calculator. So in this case, N is 30, and we're selecting 12. And so let's just enter that in the calculator. So we're going to do menu, probability, it's in the probability menu, combinations, and we are going to enter 30, don't forget the comma, 12. And that's a lot. So it is 86,493,225 ways. Lots of ways. Okay, and last problem of the day. A basketball team consists of 2 centers, 5 forwards, and 4 guards. How many ways can a coach select a starting lineup of 1 center, 2 forwards, and 2 guards? So when we think of ands in this case, we think of multiplying. So from the 2 guards, I am choosing 1 times. From the 5 forwards, I'm choosing 2 times. From the 4 guards, I'm choosing 2. And so in the calculator, you're going to enter, let's enter this, menu, probability, combinations. Remember, it's a combinations. So it's going to be 2 comma 1, get out of the parenthesis, times menu, probability, combination, and now we are choosing 5 comma 2, get out of the parentheses, times, and then we're going to do menu, probability, combinations, and then 4 comma 2. And you get 120. If you did this individually, this would be 2, this would be 10, and this would be 6. And again, it would be 120 ways. Have a great weekend.